Okay, the number one question we got from our video on depth of field a few weeks ago was, why does a smaller sensor give you a greater depth of field? And so we thought we'd investigate that, and we're taking a slightly different approach to the question. Rather than digging through a bunch of equations and all the theory, we thought we'd get very, very practical. So we've designed a very elaborate test setup. We have a string of Christmas lights, and we have an LED panel here in the middle for our subject. And we're going to be testing or investigating today using a 5x7 view camera, which is about as simple of a camera as you can get with a lens on it. This is a 5x7, and we're with a 250 millimeter lens, which is maybe a little long, but pretty close to a normal field of view for a 5x7 camera. So what we're going to do now is we're going to shut the lights down, and we're going to move the video camera over and focus on the ground glass on the back of the view camera so you can see what the camera sees. Now bear in mind, since this is a view camera, the image you see is going to be upside down and mirrored. Okay, so here we are with the video focused on the ground glass, and you can see our depth of field. Our makeshift dark cloth doesn't get too much in the way. You can see the depth of field as things, as the lights go away from or closer to the camera. Now remember, these lights here are going away from the camera because we're upside down and we're mirrored. And I can walk over there and actually measure it, and I would say that we've got about a foot of depth of field on each side of that LED panel. So that's with the, as we'll call it, a 5x7 sensor. Let's switch sensors, and to do that on this camera, I can just pop this back off out of the way, and I've got a 4x5 sensor, we'll call it. This is a 4x5 back, it'll pop into place. Now there is a slight mechanical offset. Whoops, I'm going to have to refocus our view camera just a little bit, and we probably want to refocus this guy, make sure it's as sharp as it can get, and get our dark cloth back, remove some distractions. And what you can see there is, oh wow, nothing really changed. Our depth of field is about the same. Well, that frankly shouldn't surprise us, because all we've actually done here is mechanically crop the picture. We haven't changed anything optically, and what has changed is our field of view. We're literally not getting the full picture. We're getting about half of the picture. All we've done is chop the size of the image down. So the depth of field hasn't changed. And if you look at the equations, and we're not going to bore you with all the equations, but if you looked at the equations to calculate the depth of field, you would find that sensor size is not in there. Now, caveat to that, but basically sensor size is not in there. It's dependent on the focal length of the lens, aperture of the lens, and the distance to the subject. Now, I say sensor size isn't in there. The circle of confusion that we talked about before, which is a measure of how blurry you're willing to accept on the image, that is in the equation, but we're holding that constant. We're just, eyeballing it here, and so that's really not a factor. But like I say, our field of view has changed. So to really compare this, we need to adjust our field of view to the way it was with the 5x7 back. Now to do that, we have two choices. I can move the camera way back, which might involve knocking a wall out of our studio, or since this is a view camera, I can just pop this 250 millimeter lens off, and we'll put on a 150 millimeter lens, which is considered pretty much standard field of view for a 4x5 camera. And now, of course, I'm going to have to really reach around here and crank this thing back. Keep our dark cloth out of the way. We're bringing this thing back, and that looks pretty good there. We'll readjust the focus here. I think that looks pretty good. And what you can see now, have about the same, whoops, we have about the same, pretty close to the same field of view. And our depth of field, I would call it at least 3 feet in front of that light panel and probably 3 feet beyond it. So what we have is a much greater depth of field, has nothing to do with the sensor size, has everything to do with the focal length of the lens. This brings up another question that somebody asked. How did photographers, 150 years ago, get such a shallow depth of field when all they had to work with were, like f8 lenses? Nobody had an f1.4 lens back then. Well, it comes down to sensor size, actually. They were shooting huge sheets of film, like 14 by 17 inch film was fairly common. They would shoot that probably with a 400 millimeter lens. So, and in a studio at 10, 15 feet, your depth of field is going to be very, very shallow, even at f8. So hopefully that addresses your questions on sensor size and depth of field. If you have any other questions or comments, put them below. We appreciate you liking our videos and sharing it. And hopefully have another video out here fairly soon.